The wavelength is the spatial period of periodic wave, the distance over which the wave's shapes repeats. It is the distance between consecutive corresponding points of the same pace on the wave, such as two adjacent crests, throws, or zero crossings, and is a characteristic of both traveling waves and standing waves, as well as other spatial waves patterns. The inverse of the wavelength is called the spatial frequency. Wavelength is commonly designated by the Greek letter lambda. The term wavelength is also sometimes applied to modulated waves and to the sinusoidal envelopes of modulated waves or waves formed by interference of several sinusoids. The wavelength of a sine wave can be measured between any 2 points with the same pace, such as between crests on the top or throws on the bottoms, or corresponding zero crossing as shown. Assuming a sinusoidal wave moving at a fixed wave speed, wavelength is inversely proportional to frequency of the wave. Waves with higher frequency have shorter wavelengths, and lower frequency have longer wavelengths. Wavelengths depend on the medium, for example, vacuum, air, or water, that a wave travels through. Examples of waves are sound waves, light, water waves, and periodic electrical signals in a conductor. A sound wave is a variation in air pressure, while in a light and other electromagnetic radiation, the strength of the electric and the magnetic field vary. Water waves are variation in the heights of a body of water. In crystal lattice vibration, atomic position vary. The range of wavelengths or frequency for wave phenomena is called a spectrum. The name originated with the visible light spectrum, but now can be applied to entire electromagnetic spectrum as well as to a sound spectrum or vibration spectrum.
Good day. My name is Charisse Diamante. I will be reporting for antennas. What is antenna? Antenna is a device is used for transmitting and receiving signals, which is represent some information. It was invented in the year 1888 by Germans. They are designed for wireless communication and have the capability to propagate both radio and microwave signals. Basically, it is just like a conductor and a resonant device, which works on a very narrow frequency band. An antenna is a metallic structure that captures and or transmits radio electromagnetic waves. Antennas come in all shapes and size, from little ones that can be found on your roof to the watch TV, to really big ones that capture signals from satellites millions of miles away. An antenna is a device radiates or receives radio frequency signals. Also, antenna is a device that can be as simple as a single wire or as complex as a large dish. It depends on the application. What are the three types of antenna? The three types of antenna are directional, semi-directional, and omnidirectional. Directional antenna is a kind of antenna that radiates power in one or more directions. This capability generally allows a directional antenna to maintain increased performance in transmitting and receiving transmissions. It can be also focus all its strength and transmitting power in one general direction, thus optimizing it is a signal strength and minimizing loss of signals. Most of directional antennas also have the ability to reduce interference from several sources. This often makes them the most ideal among to be used in areas that have a lot of interference. This interference often comes from the other transmitting devices like microwave ovens, weather conditions, and other obstructions that may be man-made or natural. Directional antennas. Directional antennas must be pointed toward a cell tower. As you can see in the drawing, the directional antennas is appointed. And number 2, semi-directional antennas. Semi-directional antennas are designed to direct the radio frequency signal in a specific direction for point-to-point communication. Semi-directional antennas are used for short, medium-distance communication indoors or outdoors. A good way to think of how the semi-directional antenna radiates radio frequency is to think of it as strength lamp shining down on the street. It is common to use semi-directional antenna in a campus-like environment since they can be provide network bridge between two buildings. Semi-directional antennas is antennas cover a broad elongated area and are well suited to cover rooms along hallway where the antenna is located of one end of the area. They can also be used to cover broad outdoor areas away from building. Semi-directional antenna is more specific pattern antenna versus omnidirectional antenna. Types of semi-directional category. Number 1, Yagi antennas. Yagi Oda antennas are typically used for short to medium distance point-to-point communications of up to about 2 miles, although they high gain. Yagi antennas can be used for longer distance. Patch antennas. Patch refers to a particular way of designing the radiating elements inside the antennas. And number 3 is panel antennas. Radiation patterns of a typical semi-directional panel antenna. That's the 3 types of semi-directional category. The Yagi antennas, patch antennas, and panel antennas. And number 3 is omnidirectional antennas. An omnidirectional antenna is a wireless transmitting or receiving antenna that radiates or intercepts radio frequency or RF, electromagnetic fields equality will in all horizontal directions in a flat, two-dimensional or 2D geometric plane. Omnidirectional antennas are used in the most consumer radio frequency wireless devices, including cellular telephone sets and wireless routers. That's all. Thank you.
Good day, everyone. My name is Ebel de Los Santos. The topic that are assigned to us is about wavelength and antennas. The topic that is assigned to me is about different types of wavelength. Different types of wavelength in electromagnetic spectrum. The electromagnetic spectrum is generally divided into 7 regions, in order of decreasing wavelength and increasing energy and frequency. The common designations are radio waves, microwaves, infrared or IR, visible light, ultraviolet or UV light, X-rays, and gamma rays. Radio wave. Number 1, radio waves. Radio waves are the lowest range of the electromagnetic spectrum, with frequencies of up to about 30 billion Hz or 30 gigahertz, and wavelengths greater than about 0.4 inch to 10 millimeters. Radio is used primarily for communications, including voice data and entertainment media. Pangalawa, microwaves. Microwaves fall in the range of electromagnetic spectrum between radio and IR. They have frequencies from about 3 gigahertz to 30 trillion hertz or 30 terahertz, and wavelengths of about 0.004 to 0.4 inch, 0.1 to 10 millimeters. Microwaves are used for high bandwidth communications and radar, as well as for a heat source for microwave ovens and industrial application. Number 3, infrared. Infrared is in the range of electromagnetic spectrum between microwaves and visible light. IR has frequencies from about 30 to 400 terahertz and wavelengths of about 0.0003 to 0.004 inch, 70 nanometers to 100 micrometers. IR light is visible to human eyes, but we can feel it as heat if the intensity is sufficient. Number 4. Visible light. Visible light is found in the middle of electromagnetic spectrum between IR and UV. It has frequencies of about 0.00015 to 0.00003 inch, 380 to 740 nanometers. More generally, visible light is defined as the wavelengths that are visible to human eyes. Number 5. Ultraviolet. Ultraviolet light is the range of electromagnetic spectrum between visible light and X-rays. It has frequencies of about 80 by 10 14 to 3 times 10 16 Hz and wavelengths of about 0.000004 to 0.00015 inch, 10 to 318 nanometers. UV light is a component of sunlight, but it is invisible to the human eye. It has numerous medical and industrial applications, but it can damage living tissue. Number 6. X-rays. X-rays are roughly classified into two types. Of about 3 by 10, 16 to 10, 18 Hz and wavelengths of about 4 times 10 minus 7 to 4 to 10 nanometers. Hard X-rays occupy the same region of electromagnetic spectrum as gamma rays. The only difference then is their source. X-rays are produced by accelerating electrons, while gamma rays are produced by atomic nuclei. Number 7. Gamma rays. Gamma rays are in the range of spectrum above soft X-rays. Gamma rays have frequencies greater than about 10-18 Hz and wavelengths of less than 4 by 10 to 9 inches, 100 picometers. Gamma radiation causes damage to living tissue.
Hi everyone, I will discuss about different type of antenna. Here are the different type of antennas. The different type of antenna are wire antenna, aperture antenna, reflector antenna, lens antenna, microstrip antenna, and array antenna. Wire antenna are the basic type of antennas. These are well-known and widely-used antennas. Wire antennas application is personal application like buildings, ships, automobile, and spacecraft. Here are the example of wire antenna. One is dipole antenna. Dipole antenna or doublet is a simplest and most widely used class of antenna. Dipole antenna is a class of antennas that producing a radiation pattern approximating that of an elementary electric dipole with a radiating supporting a line current so energized that the current has only one node at each end. And the second one is monopole antenna. A similar half-structured for a folded antenna is called a folded monopole antenna. The presence of the ground plane allows the monopole antenna to separate as electrically equivalent to a dipole antenna. And the third one is helix antenna. Helical antenna or helix antenna is the antenna in which the conducting wire is wood in helical shape and connected to the ground plate with a feeder line. It is a simplest antenna which provides circularly polarized waves. And the fourth one is loop antenna. An RF current carrying coil is given a single turn into a loop. Can be used as an antenna called as loop antenna. The currents through this loop antenna will be in phase. The magnetic field will be perpendicular to the wall loop carrying to the current. Aperture antenna. In electromagnetic and antenna theory, the aperture of antenna is defined as a surface near or an antenna on which it is convenient to make assumption regarding the field value for the purpose of computing field at the external point. Its application is flash-mounted application, aircrafts, spacecrafts. Here are the example of aperture. Waveguide opening. A waveguide is a structure that guides waves, such as electromagnetic waves or sound, with minimal loss of energy by restricting the transmission of energy to one direction. And another one is horn antenna. A horn antenna or microwave horn is an antenna that consists of a flaring metal waveguides shaped like a horn to direct radio wave and beam. Reflector antenna is a device that reflects electromagnetic waves. Its application is microwave communication, satellite tracking, and radio astronomy. Its example is parabolic reflectors and corner reflectors. Parabolic reflectors is direct the radio waves to the receiver in its focal points, while the corner reflectors is directly toward to the source but translate. Lens antenna. It is used the curved surface for both transmission and reception. Its application is used for very high frequency application. The example of lens antenna is convex plane, concave plane, convex-convex, concave-concave lenses. When we talk about lenses, the focal point is the point from where the light rays seems to diverge. Microstrip antenna. In telecommunication, a microstrip antenna, also known as printed antenna, usually means an antenna fabricated using photolithograph techniques on a printed circuit board or PCB. Its application is aircrafts, spacecrafts, satellite, missiles, cars, mobile phone, and etc. Microstrip antenna, the multiplexing transmission, has always been focus of attention for communication technology. And the last one is array antenna. It is a set of multiple connected antennas which work together as a single antenna to transmit or receive radio waves. Its application is used for very high gain application, mostly when need to control the radiation pattern. Its example is UGUSA antenna, consists of a single driven element connected to a radio transmitter or receiver through a transmission line. And microstrip patch array, it is a single layer design. Aperture array, the antenna elements coupled to appropriate receiver systems which can be arranged in a regular or random pattern on the ground. And the last one is slotted waveguide array. It is used in radar, communication, and remote sensing system for high frequency.
My name is Charisse Ann Garcia Aco, and the topic was assigned to me is about the formula of wavelengths. Wavelengths, distance between corresponding points of two consecutive waves. Corresponding points refers to two points or particles in the same phase. Points that have completed identical fraction of their periodic motion, usually in transverse waves, waves with points oscillating at right angles to the direction of their advance. Wavelength is measured from crest to crest or from true to true. In longitudinal waves, waves with points vibrating in the same direction as their advance. It is measured from compression to compression or from rarefaction to rarefaction. Wavelength is usually denoted by the Greek letter lambda. It is equal to the speed of a wave train in a medium divided by its frequency. Calculating wavelength. Wave speed is represented by the variable b, frequency, cycles per second by f, and the wavelength, cycle length, by the Greek letter